Hello everyone, welcome to the presentation. My name is M. Bhaskar-Reddy. Today I am going to present module number 2, switching concept. First of all, we are going to see what are the objectives in this module. There are two objectives. The first one is frame forwarding. In that, you are going to explain how frames are forwarded in a switched network. There are two frame forwarding techniques, that is store and forward method and cut through method you are going to learn. And the second objective is switching domains. So in switching domains, we have two domains, collision domain and broadcast domain. So you are going to compare what is collision domain and what is broadcast domain, what are the difference between these two, how to identify the number of collision domains and broadcast domains. First topic is 2.1 frame forwarding. Before entering this topic, you need some basic concepts, okay? I'm going to discuss now. First of all, you must learn some names like what is a ingress and what is an egress. Two terms are associated with frames entering or leaving. Ingress means in. Egress means like exit, just for general understanding, okay? Ingress means in and egress means exit, okay? Ingress means entering the interface, egress means exiting the interface. For example, if you take a switch here like this one, port number 1, port number 2, some frame is entering, this port is called ingress port, and the frame is exiting here, this port is called egress port, okay? Here port number 1 is ingress port. Why? Because the frame is entering the switch, okay, on this interface, and here the frame is exiting the interface. That's why we say it is a egress port or egress interface, like this one, okay? So these are the two terms you must understand, because we are going to use frequently the ingress and egress ports concept, okay? Next one, you must know what the difference between the hub as well as switch, okay? Because if you want to learn about collision domains and broadcast domains, you must be fully aware about how the switch is going to work and how the hub is going to work, okay? So what is hub, how it will work, we are going to see now. For example, this is the hub. For this hub, there are three devices are connected. The names are host A, host B and host C. For example, the host A is sending the frame here, thus that frame received by the hub. The hub is not an intelligent device, okay? Hub will simply forward to all the ports which are connected to the hub, okay? So from host A, I want to send a frame to host B. Is it possible in hub? No, not possible. When the frame received by the hub is going to broadcast all the devices connected to the hub except the ingress port, means from where the frame received, okay? That is what the hub, okay? So if you take the hub, if any frame comes here to the hub here like this one, the hub will broadcast to everyone who are connected to this hub. That is the purpose of hub, because the hub is not intelligent device. Why we are going to say hub is not intelligent device? Because there is no MAC address table. Simply it will broadcast to all. Next, this drawback we are eliminated in switch, okay? In switch, for example, I want to send a frame from host A to host B. Is it possible? Yes, it is possible. For example, host A is sending a frame. This frame only sent to host B. This is possible in switch because switch is an intelligent device. How we are going to say switch is intelligent device? Because it is going to maintain the MAC address table. That's why we are going to say the switch is intelligent device. So what are the elements are there in MAC address table? The MAC address table contains the two parts, the port and MAC address of the device, okay? These two fields are there in MAC address table. You see here, if we want to send a frame from host A to host B, from host A to host B, the switch will forward the frame only to host B based on MAC address table. So we are going to say the switch is an intelligent device. This is the basic concept. Now, in really, if you take brand new switch, how the switch is going to work, we are going to see now. Okay. For example, see the scenario number 1. For example, we are connected to the switch, 3 hosts, host A, host B, and host C. The host A is connected with port number 1, the host B is connected on port number 2, and host C is connected on port number 3. The source MAC address of the host A is, for example, just for understanding, AAA. The source MAC address of host B is just BBB. The source MAC address of host C is CCC. So initially there is no communication and brand new switch, and the MAC table is empty. This MAC table is empty. There is any data is there inside the MAC table? No, the MAC table is empty. So what is there in MAC table? The port that is ingress or egress ports, as well as the MAC address is there. Okay, this is the first one we are going to see. Next, second one. Now I want to send a frame from host A to host B. So my target is I want to send a frame from host A to host B only. So how this process is going to occur? Okay, so I'm going to send a frame from host A to host B. First, host A is sending a frame. You must understand what is there inside the frame. Okay, so what is there inside the frame? Each frame contains the source MAC address, the destination MAC address, followed by type. It means the network layer data, and followed by the data, and FCS means error checking. This one. Okay, so these are the elements as part of frame header. Okay, so it contains source MAC address, destination MAC address, type, data, and FCS. See here, now I want to send the frame from host A to host B. So what is the MAC address of host A is AAA. This is my source. My destination MAC address is host B. What the MAC address of destination is? Just for understanding, I put BBB. So the source MAC address is AAA and the destination MAC address is BBB. Now I am sending a frame to the switch. Okay, so whenever this is what the frame ingress port. Okay, the frame entered the switch on port number 1. Now once the frame received by the switch will record from where this frame comes from. It is going to record port number how much? 1. And what is the MAC address of the frame is AAA. From this source and from this port I received the frame. Now the frame is with the switch, right? Now the switch is going to open the frame and check for destination MAC address inside the MAC table. There is any destination MAC address is recorded in the table? No, it is not recorded. So what the switch is going to do? Switch is going to work like a hub. Switch is going to broadcast this frame to host B as well as host C. Just remember this logic. Okay, when the frame arrives at the switch will open the frame and check for destination MAC address in the MAC table. If it is available, it will forward, but there is no destination MAC address, is not, that is BBB is not found in the MAC address table. So what the switch is going to do? Switch is going to forward the frame to host B as well as host C. Now this frame is received by host B. Now the host B is going to open the frame and check the destination MAC address. So the destination MAC address is BBB and both are matched. Okay, host B think this is my frame, like this one. Similarly, if the same frame should be also sent to host C also. Host C receive the frame and open the frame and check the destination MAC address. But the destination MAC address is there BBB, but my MAC address here is CCC. So the host C is going to discard or delete your frame. So this is the how the switch is going to fill the MAC table. This is point number 2. Now coming to the third option, now host B want a send a frame to host A. Now we are going to see the communication from host B to host A. How this communication will occur. Now we are going to see. See here, host B. What is the MAC address of this one is? BBB. Okay. And what is the MAC address of host A is? AAA. That is what we learned before. And this is the MAC address is CCC. Now I want to send a frame from host B to host A. See here, the host B is sending the frame. This frame contains, this is the source MAC address, and this is the destination MAC address, and followed by type, data, and FCS is there. Okay. Now what is the source? BBB. My destination is AAA. Now the frame come to the switch. Okay, on the ingress port F0/2. Now the switch will record this interface F02, and the frame comes from the source MAC address is BBB, like this one. Now the switch received the frame, and the switch will check the MAC table. Okay, what is the destination is available? The destination MAC address is available in the MAC table or not? Now the switch is going to open the frame and check the destination MAC address. The destination MAC address here is AAA. So AAA is available on port number FA0/1. So it will forward to host A. In this context, it will not send to C. There is nowhere C is involved, because the switch knows what is the egress port, okay, how to forward the frame to the destination. So this is how the switch is going to build the MAC address table. Okay, so that's all about how the switch is going to work, how the MAC table is going to complete. Okay, that's it. Okay, so I'm going to revise once again all the concepts here. So initially the switch MAC table is empty, so it is going to, nothing is recorded in the MAC table. Now I want to send a frame from host A to host B. So the frame contains the source MAC address, destination MAC address, etc. So the host A is sending the frame to the switch. So in ingress port or in port number 1 is recorded, the source MAC address is also recorded, and the switch don't know where is the MAC address, where is the destination MAC address and egress port. So the switch will forward to both all the devices connected to the switch. So each device receive the frame and check the destination MAC address. If it is matches, it will keep. If it is not matches, it will discard the frame. In the third context here, I want to send a frame from host B to host A. Then it will record from ingress port FA02 BBB, and it will check the destination MAC address is AAA. So in the MAC table already AAA is found. It will forward to only host A. Okay, right. Now we are going to see each switch is going to maintain MAC table. That's why we are telling the switch is intelligent device. The switch is going to operate at layer 2, that is data link layer of OSI model. Okay, this is what we can say the traditional switches. Okay, see here, switch will use the destination MAC address and the egress port to build the MAC table. These are the very two important points here. How the switch is going to build the MAC address table based upon the destination MAC address plus egress port. So that is what I discussed in the previous slide. The egress port here are the port as well as the MAC address, same. Okay, so the switch will build the MAC address table based upon the destination MAC address as well as the interface. The switch will build the MAC address table. This MAC address table, sometimes we are going to say CAM table also. So MAC table, or you can say CAM table, means both are same. Okay, so also known as CAM means content addressable memory. content addressable memory table, CAM table. Okay, so this is the concept how the switch is going to build the MAC address table. What are the different elements are there in MAC address table? So the MAC address table contains the MAC address as well as the egress port. That is the basic concepts we covered. Now we are entering the first objective, the switch frame forwarding methods. Okay, totally there are two switch frame forwarding methods are there. The first one is the store and forward method. The second one is cut through method. What is the difference between store and forward method? What is cut through method? Okay, we are going to see. In store and forward method, see here, receives the entire frame and ensure the frame is valid. Store and forward switching is Cisco preferred switching method. Okay, so before that I'm going to show you one video, you will understand. Okay, see here, this is the store and forward switching. For example, this is my source, this is my destination. I want to send a frame from this source to this destination. How the switch will forward the frame? See here, this is the frame and the switch is the source is forwarding the frame to the switch. See, now the frame is received by the switch. What the switch is going to do? The switch will receive the entire frame and check the CRC, cyclic redundancy check value. If both are matches, means the frame is good, and then it will forward the frame to the destination. Frame is good, it will check the destination MAC address, identify the egress port and forward to the destination. That is what the store and forward method. See here, a store and forward switch receives the entire frame. That is the more important point. Here the switch receives the entire frame. For example, just for understanding, the frame is like 10 bytes. The full frame, 10 bytes of frame received by the switch, then only it will forward. See, 10 bytes of frame received by the switch, the full frame, then it will check this frame is whether good or bad. If the frame is good, then it will forward. If the frame is bad, it will be removed at this spot itself. Okay, how the switch will check whether the frame is good or bad? For that, it is going to use the mechanism CRC, okay, cyclic redundancy check method. Okay, by using this, it is going to validate whether the frame is good or bad. Okay, I'm going to play the video once again. See here, this is the frame. It is going to send by the source. The switch receives the full frame. That is the point here. The switch receives entire frame, full frame it is received. Then it will check the CRC. What is the purpose of this CRC is, the switch is verifying whether the frame is good or bad. So it is verified the CRC value. Based upon that, it is understand the frame is good. Now it will check the MAC table, where is the destination and what is the egress port. Based upon that, it will forward the switching table means MAC table only. Okay, from this it is going to forward the frame to the destination. This is how the store and forward method is going to work. So go for the concept. A store and forward switch receives the entire frame and computes, means calculate the CRC. If the CRC is valid, means the frame is good, the switch looks up the destination address, which determine the outgoing interface. The frame is forwarded to the correct port. So I'm coming back to the PPT here. See here, in store and forward method, the switch receives entire frame. That is the keyword here. The switch receives the full frame, entire frame, and ensure the frame is valid. How it is going to check whether the frame is valid, means good or bad? For this, it is going to use the mechanism called CRC, means cyclic redundancy check method. Okay, by using CRC, it will check whether the frame is good or bad. Okay, that's all about. This is how the store and forward switching method, the switch will forward the frame. This is most preferred method by Cisco devices. Okay, so most of the Cisco switches, even some other switches also, other vendors also going to follow the store and forward method. Okay, so but for Cisco, the preferred switching method is store and forward method. Okay, compared to these two methods, Cisco preferred is store and forward switching method. The second one, cut through switching. I told you in store and forward method, for example, this is a switch, this is the full frame received, and forward the full frame if the frame is good, like this one. But if you go for the cut through method, it is not different. For example, this is the frame, this is the switch. For example, imagine the switch received half of the frame and then forward to the destination. This is what here in cut through switching. Now we are going to see how cut through is going to work. Okay, so coming back here, the second method is cut through switching. See here, if you go for the cut through switching here, this is the source, this is the destination here. Again, see, I'm going to play from here, from destination to source. I want to send a frame. So this PC, the destination is sending a frame to the switch. See here, there is no CRC here. The switch is not going to validate whether the frame is good or bad. Whenever the frame received by the switch is able to identify the destination MAC address and egress port, blindly switch will forward the frame. See here, then the switch will check the destination MAC address and forward the frame to the destination. Here, see here, a cut through switch forward the frame before it entirely received. In Soren method is this opposite. You must receive the full frame, but here no need to receive the full frame. At a minimum, the destination address of the frame must be read. So the frame able to read the destination MAC address, that is enough. Like half of the frame, it received the destination MAC address, just it will be forwarded. Okay, before the frame can be forwarded. Okay, so I'm going to again play this one. Forwarding the frame to the switch. Now the frame received by the switch is able to identify what is the destination MAC address and forward the frame to the destination based upon the egress port. Okay, so this is what the cut through switching forwards. In cut through switching, forwards the frame immediately after determining the destination MAC address. Okay, please remember this one, because if you check the frame header, okay, you will understand more detail. Okay, forward the frame immediately and determine the destination MAC address of the incoming frame and the egress port. Okay, so whenever it identifies the destination MAC address and egress port, it will forward the frame. This is what cut through method. So what is the difference between store and forward and cut through method? In store and forward method, the full frame should be received and check the frame is good or bad and forward it. Okay, in cut through method, there is no need to wait. Whenever the switch receives, for example, like half of the frame, it will be able to identify the destination address and the egress port. It will forward the frame. That's it. Okay. See here, that is what I'm giving the theory. Store and forward method. See here, a store and forward switch receives the entire frame and computes CRC. The CRC is valid. The switch look up the destination address and outgoing interface from the MAC table. The frame is forwarded to the correct port, like this one. And the second one is cut through method. A cut through switch forwards the frame before it entirely received. At a minimum, the destination address as well as the egress port the destination address of the frame must be read before the frame should be forwarded. Okay, this is the cut through switching method. Now we are going more detail of the characteristics here. Okay, store and forward has two primary characteristics like error checking and buffering. Buffering means the switch is able to store the frame. See the frame header. From this you will understand here. See here, this is the entire frame, right? This is the entire frame. This is the starting of the frame. This is the start. This part is called end of the frame. Okay, so this is the starting of the frame. This is the end of the frame. In between this one is the upper layer data, that is data with transport layer header and network layer header. So this is the frame. So the frame contains the frame header as well as that is the starting as well as the frame ending part. Okay, this is the end operation. Okay, end of the frame, right? So what is there inside the frame header? Okay, so the frame header contains the, I told you, the source MAC address, destination MAC address, preamble and type. At end of the frame contains FCS checksum, that is CRC, cycle redundancy check. See here, the preamble is 8 bytes, the destination MAC address is 6 bytes, the source MAC address is 6 bytes, and type is 2 bytes, and CRC or FCS checksum is 4 bytes. What you understand from this one, in store and forward method, see the arrow mark here, this arrow mark, see this arrow mark here, the full frame should be received by the switch, means this is the full frame, right? This is the full frame, means this is the full frame, right? The full frame should be received by the switch. See, store and forward switch entails receipt of the entire frame, like jumbo frame. This we will say entire frame is full frame before forwarding decision is made. So it is going to check from the starting to ending the entire frame. That is the what the store and forward method. So the store and forward method is going to support for error checking as well as buffering, means the entire frame is going to store inside the switch. The second one is in cut through switching method. What will be happened here? So this is the starting of the frame, this is the ending of the frame, this is the upper layer data here, right? Now in the frame header, same parameters are here: preamble, source MAC address, destination MAC address, as well as type, as well as checksum. But in cut through method, the full frame is not going to identify. It will check, see here, it will check only these two. See here, it is going to check only it is going to identify only the destination MAC address. As long as you know the destination MAC address, the frame will be forwarded to the destination. This is what the cut through method. Okay, in cut through method, as long as you know the destination, that's enough. The frame will be forwarded. See here, frames can be begun to forward as soon as the destination MAC address is received. So cut through forwards the frame immediately after determining the destination MAC address. Okay, so that's all about the first objective here is the store and forward and cut through frame forwarding methods. Okay, so if you want, I'm just going to recap whatever I teach. So the switch frame forward methods are two types: store and forward method and cut through method. What is store and forward? Store and forward switching is the switch is going to receive the entire frame and check the frame is good or bad by using CRC, and based upon MAC address table, the destination MAC address as well as egress port, it will forward the frame. But in cut through method, not like that. As long as the frame received, it is able to identify the destination MAC address, the frame will be forwarded to the destination. This is what cut through method. Which method you prefer in Cisco device, Cisco switches, is the Cisco switches are going to prefer the store and forward switching method. Okay, which one is more advantage is this one. Okay, store and forward switching, because it is going to check the without errors. Okay, this is a theory. So if you want to understand the theory definitions like this one, you have to write this one. Okay, store and forward method, and this for cut through method. Okay, so this is the first objective we learned. Okay, so if you check here, the entire frame is going to check because it is jumbo frame and check the error, and this is store and forward method. But if you go for cut through method, only as long as you know the destination MAC address, the frame will be forwarded. The next concept here is 2.2 switching domains. Okay, so we are going to see in switching domain, there are two concepts, collision domains and broadcast domains. Okay. So before coming to this slide, just I want to, you must understanding what is collision domain, what is broadcast domain. What is a domain? Domain means we can say it is an area. Okay. It is an area that is called a domain. See here, understand collision domain in case of hub, understanding collision domains in case of switch. What is the difference between these two? See here, for example, there are people here. There is a person number 1 here and person number 2 here, and there is one more device here. For example, 3 devices are sharing, okay, the same transmission medium. Okay, for example, if I am sending the data, 2 and 3 cannot send. That is what we learn about in, I think you learn in fundamentals 1 and 2, CSMA CD technique. Okay, carrier sense multiple access collision detection method. For example, this host 1 is sending the data, automatically 2 and 3 sense he is sending the data. I cannot send the data like this one. This is the case number 1. This is well and good. Okay, this is fine. For example, in the second case, see here, in a scenario number 2, for example, A and B want to send, for example, host A, for example, host 1 and host 2 is sending, because both are checking the cable is free or the medium is free. So both try to send the data at the same time. Yes, there is a collision. Okay, there is a collision. For example, both people try to access the medium at the same time. There is a collision. So we cannot avoid collisions in case of shared medium. Okay, that is the point, that is the conclusion here. So it is not possible to avoid collision in case of shared medium. So the point here is, from this concept we are coming to here. For example, the hub is going to use the shared medium. Okay, the hub is going to use which one? Shared medium. Okay, the hub is going to use the shared medium here. Now, for example, this PC is sending the data at the time. I'm going back here, the context 1. In context 1, this PC is sending the data. This PC and everyone is not allowed to transmit anything. That is context number 1. For example, in scenario number 2, see here, for example, this PC and this PC is sending the data at the same time, and there is a collision occur. Okay, and there is a collision possible. Okay, so in hub there is a collisions. So in hub we are going to say one collision domain. Okay, so the hub we are going to say it is one collision domain. We can't avoid collisions in case of hub. Why? Because the hub is going to use the shared medium. So if one person is sending, remaining people are not sending the data, no issue. But two people try to access or try to send the data at the same time, there is a collision. So we are going to consider the whole the hub concept as one collision domain. Next one, switch. If we go to the switch is not, there is no shared medium. Okay, the switch is not going to share anything. Okay, the switch is not going to share any medium here. Why the problem? See here, I'm going back here, hub. Why this problem is occurring here? The hub is not intelligent device. There is no MAC table here. That's why if you send the data, he send the data, and it is going to broadcast to everyone. That is what you learn about hub. But if you go to the switch, there is no sharing here. For example, I want to send a frame from this source to this destination. So this PC is sending the frame. This frame only received by this PC. That's it. It is not received by this one, and it is not received by here, it is not received by here. This is not possible. So why this from source to destination only we can transfer? Because the switch is going to use MAC table. Okay, based upon MAC table, it will forward to a particular source to particular destination is possible in case of switch. Okay, so there is no shared medium in the switch, but in case of hub there is a shared medium. So we are going to consider the hub is one collision domain. So the point here is the collisions are occur in case of hub, but we avoid these collisions in case of switch. In switch, most of the cases we are going to eliminate the collisions, but in hub definitely there is a collision. These collisions are avoided in case of switch. How we will avoid it? Because the switch is intelligent device, it is using MAC table. By using this MAC table, I can send only two data. For example, see at the same time, see the one more context here, context number 2. For example, he is sending the data at the same time, he is also going to send the data to here. There is no collision because both people send the data at the same time, no issue, there is no collision because based upon MAC table, the switch will forward the data. Here, there is no MAC table, simply he send the data and he send the data. Both data should be sent by this hub will forward to everyone. So there is a collision, but here there is no collision at all. Okay, so but how to identify the collision domains in case of switch? Okay, in switch, each switch interface, that is each connection, see here each switch interface work like a collision domain. Okay, for example, if you go here, the switch, this is the switch. In the switch, I am connected to each interface or each connection work like a one collision domain. Okay, so this is how you are going to understand this one. Okay, this is how we are going to understand the collision domains. Okay, so I'm just going to repeat here. The hub, actually there is no collisions because if this PC is sending, nobody will send the data, but two devices try to send the data at the same time, there is a collision. The whole area, so for example, if you take this entire area, we are going to say one collision domain. So we cannot avoid collisions in case of hub, but we will avoid collisions in case of switch. How we will avoid is there is a MAC table. So in switch, each interface, this is one collision domain, this is one collision domain, this one is one collision domain, this is one collision domain, like this one. Here each switch interface work like one collision domain, and there is no collisions here. For example, this PC is sending the data to this PC, yes. At the same time, this PC also sending the data to this PC, yes, it is possible because the MAC table is going to work at the back and it will forward the data without any collisions. Okay, so what is the difference between the hub as well as switch here? The entire area of the hub we are going to consider as one collision domain, but in switch, each interface is a separate collision domain. Okay, so I'm going back here, right? See here, this entire area is how many collision domains are there here? How many collision domains are here? There is only one collision domain. Okay, but here each interface work like collision domain. That's why 1, 2, 3, 4, 5. Right here, the number of collision domains are 5. So that's all about collision domains. Collision domain is nothing but a group of devices sharing the same bandwidth. There is a possibility of collision. So in hub, there is a collision. In switch, we will avoid this collision with the help of the MAC table. But what is difference here is the entire domain, we are going to say one collision domain in case of hub, but in switch, each interface work like a separate collision domain. Next one is the broadcast domain. So what is a broadcast domain? I think you know about broadcasting. For example, here, if you see here, for example, okay, this PC is sending the frame, this received by the switch, this switch will broadcast to this switch will broadcast to this PC, as well as the switch will broadcast to the router, like this one, right? So what happened here is the PC sending a frame received by the switch by default, it is going to broadcast to other switches, other PCs, including router. But the router is going to break this broadcast domain. See, router cannot broadcast to other network. So within the LAN or within the area, this is what domain, okay? Within the area, only the switch will send the frame. Whenever it reaches the router will stop this broadcast domain. This is the first one. For example, I am removing these switches. I put which one? Hubs, okay? So if I put the hub here, hub also same. For example, the PC sending the data to hub. This hub will forward the data to this hub. This hub will broadcast to this PC, as well as this hub will broadcast to this router. Again, the router will break this broadcast domain, and within the network, within the local area network, the frame will be broadcasted. You can use either switch or hub. So the point here is we can't avoid broadcast in case of switches. So by using switch in collision, yes, we will avoid. Broadcast we are going to avoid? No, it is not possible. We cannot avoid the broadcast domains, okay? If we go for the hub, okay? If we go for the hub, we can avoid collisions? No. We can avoid broadcast? No. Both are not possible in case of hub. So this is what we can say the broadcast domain, the full area. So who is going to break the broadcast? The router is going to, router can't broadcast to other network, okay? See here, set of devices that receive the broadcast frames originating from any device within the LAN. So set of devices that receive broadcast frames originating from any device. For example, here to here, there is a broadcasting, but once it comes to the router is going to block this broadcast domain, okay? So the point conclusion here is the switch is going to break the collision domains, but it can't break the broadcast domain. If you come to the hub is not going to break collision as well as broadcast domain. Both will be there, okay? So that's all about the theory part about collision and broadcast domains. See here, switch eliminate collision domains and reduce congestion. That is what we learned, okay? So how the switch is eliminating the collisions? By using MAC table. When there is a full duplex on the link, the collision domains are eliminated. So you are in full duplex mode, definitely there is no collisions. When there are one or more devices in half duplex, there will be collision domain. So that is what I discussed in chapter number 1. The hub is a half duplex device. It is going to support for half duplex. The switch is going to support for half as well as full, okay? That's why we are telling there is a half duplex, there is one-way communication. At the same time, two people try to access the same time, there is a collision. But in switch, full duplex mode mostly, so there is no collisions like this one, okay? Now, see here the broadcast domain, same theory. Only layer 3 device, router, will break the broadcast domain, also called MAC broadcast domain, okay? When the layer 2 switch receives the broadcast, it will flood. That is what I told, all interface except the ingress interface. Too many broadcasts may cause congestion and poor network performance because more load on network, okay? So that is what I told here. So the router is going to break the broadcast domain, but within the switches there is a broadcast is there, okay? In hub also there is broadcasting is there, okay? Now, what is the conclusion? What we learned here is, this is what the conclusion, broadcast versus collision domain. In hub, there is only one broadcast domain and only one collision domain. in switch, there is only one broadcast domain and multiple collision domains. So how to identify the multiple collision domains means in the switch, every port is one collision domain because based upon that one. If you go to the router, every port is a broadcast as well as collision domain. Okay, so in router, every port is a broadcast and collision domain. Okay, so that's all about this one, collision and broadcast domain. If you want, you can go watch different videos in YouTube. You get the good concept also. Okay, so that's all about this one, understanding what is collision domain and broadcast domain. So this is the theory part, but actually if you come to the industrial exam or any exams, you have to identify the number of collision domains and broadcast domains in any network. Okay, they give you some topology. From that you have to identify how many number of collision domains are there as well as how many number of broadcast domains are there. This is the what important. Okay, for that I am given some logic. Okay, based upon this logic, very easy to understand how many collision domains are there, how many number of broadcast domains are there in a given topology. Okay, see the logic. Collision domains, I'm going to put the logic. Collision domain means number of connections to switch as well as router. Okay, so number of connections, for example here this switch as like this one, connecting with router here like this one, and connecting with one more. What I'm telling, how to identify the collision domains, this is the concept here. Number of connections to means number of cables, clear? So number of connections means number of cables here. So number of connections means cables to switch and router. See here, the switch has one connection here, the switch has another connection here, this switch has switch and router, there is one more connection. So totally how many collision domains are there? 3. Like that we will identify number of connections to switch plus router. Okay, just in my way of understanding I write easily like this one. Okay, if you understand differently, you can follow that method also. Okay, now the broadcast domain, how to identify the broadcast domain. See here, for example, as you know, how many LANs are there? This is the LAN number 1, this is the LAN number 2. See, number of networks, that is number of connections to the router, that is what we are I put here, that is what we can say the broadcast domain means number of networks. See here, for this router this is one network, this is the other network, this is one connection, this is the other connection. So like that we will identify the number of broadcast domains. Okay, so how to identify number of collision domains, how to identify number of broadcast domains. Okay, please take note in paper, then only you can go to the next rest of the video. Okay, so how to identify collision domains means number of connections to switch plus router. How to identify number of broadcast domains means broadcast means number of networks. Okay, so how many networks are connected to the router. So for this router, for example here 1 2 3 networks are there. Okay, so we can say the broadcast, how many broadcast domains are here is how many? 3, like this one. Okay, but there is a note, this I think I already discussed. So by default the number of collision and broadcast domains for hub is how many? Only 1. Okay, so the number of collision and broadcast domains for hub is only 1. Okay, so this is the logic, very important, and please note, then go to the examples. Okay, so identify the number of collision and broadcast domains, how you are going to identify. Okay, so now I am going to the next video, we are going to identify here. Okay, example number 1. Example number 1, see, they are given this diagram. Okay, what we understand, the hub is going to work like a single broadcast domain as well as single collision domain. See the question, draw individual shapes around each broadcast domain. So the question is here, okay, how many broadcast domains are there? Okay, how many broadcast domains are here. Okay, so how many broadcast domains are there? As we know, the number of broadcast and collision domains in a hub is, we are going to consider as only one. So we are going to consider the whole area like this one as one broadcast domain. See the answer in the next slide. The answer is this one. Okay, right. So only one broadcast domain is available. Okay, so the number of broadcast domains here is how many? Only one. That's it. Okay, next example number 2, question number 2. Draw individual shapes around each broadcast domain. So again the question is, how many broadcast domains are there? What is a broadcast domain? Broadcast domain means number of networks, right? Now there is a router here. How many broadcast domains are there? Number of connections to the router. Okay, so how many connections are there? Only one. So how many broadcast domains are there? Only one. See here what I write, number of networks, that is number of connections to which one? Router. So if you check this diagram, the number of connections to router is only, how many is there? Only one, this one, right? So the number of broadcast domains are only one. The answer is how much? 1. See here, the answer is only 1. Next, question number 3. Draw individual shapes around each collision domains. Okay, so what is the logic for collision domain? If you go to the logic, number of connections to switch as well as router. Okay, so if you go to the here, question number 3, number of connections to switch, there is one connection here, there is one connection here, in switch to router also there is one connection. Totally how many? 1, 2, 3. So the number of collision domains is how many? 3. Okay, so you can, from this you will identify the number of collision domains are 1, 2 and 3. See here, the answer is C. 1, this is the 2, this is the third one. Okay, that's all about the question number 3. Next, question number 4. Draw individual shapes around collision domains. So collision domains means number of connections to switch as well as router. Okay, so 1, 2, 3, 4, 5, 6, 7. So I am going to write the answer for this. Here is how many? 7 collision domains are there. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, we'll see the answer now. Yes, see here, 1, 2, 3, 4, 5, 6 and 7. That's it. Okay, like that you can answer the questions. Okay, question number 5. How many broadcast domains are there? What is the broadcast domain? Number of networks, means number of connections to router. So this is the router, it has one connection here, one connection here. So the answer here is how much? 2. So the number of broadcast domains are 2, right? So because the number of connections to, or the number of cables to router is only 2. So what is the answer? Here 1 is the second one. Next one. Question number 6. Draw individual shapes around each collision domain. So how many collision domains are there? Means number of connections to switch and router. So this is the first one. If you come to the switch, second one. Come to the switch, third one. Come to the switch, fourth one. See here, this connection and this connection all are connected to one cable, right? This is not separate one. All these 3 connections are connected to one common line. That's why this is the one we are going to consider as this is the one. So totally how many is there? 1, 2, 3, 4 and 5. So I am expecting the number of collision domains is 5. Okay, why? Because these cables are sharing the same link. Okay, that's why we are going to consider as one link. 1, 2, 3, 4, 5. We'll check the answer. How many collision domains are there here? How many? Yes, 1, 2, 3, 4 and 5. That's it, correct. Okay, next one. Question number 7. How many broadcast domains are there? There is any router? No. What is the broadcast domain? Number of connections to router. There is no routers here. The entire area we are going to take as one LAN network. That's why the number of broadcast domains here is how many? Only 1. You got the point here, I think. There is no router, means these what one LAN network. We are maintaining switches, hubs as well as servers, all these things, the host missions, everything comes under one LAN network. So the number of broadcast domains is only one. We'll check the answer for this one. Right. Good. Okay. Now, question number 8. Draw individual shapes around each collision domain. Okay. So collision domain means number of connections to switch and router. So this is the switch. This is the connection 1. Hub we are not going to consider. Okay. Switch here 1. See here, this switch, this connection, and this connection, and this connection, all three are connected to same line. That's why we are going to consider this one as 1. So 1, 2, 3. So we are expecting the number of collision domains here is how many? 3. We'll check 1, 2, 3, right? See here, this is the one, this is the second one, this is the third one. Okay. So that's all about question number 8. Now we are going the time for practice. Okay. See here, from this diagram you have to identify how many number of collision domains are there. CD means collision domains, BD means broadcast domains. Okay. As I discussed in theory also, the switch, the hub is going to work like a single collision domain and broadcast domain. The answer for here is the number of collision domains and a broadcast domain series. How many? 1, 1. Now, coming to here, identify number of collision domains and broadcast domains. Okay. So what is a collision domain? Number of connections to the switch. Okay. And router. Okay. Here this is the one, this is the one. So number of collision domains are how many is there? 2. And broadcast domain means number of networks. This is one network, right? One LAN network. So we are going to write here is only one broadcast domain is here. Okay. Next one. Identify number of again collision domains and broadcast domain for this diagram. So collision domains means number of connections to the switch and router. So switch here 1, 2, 3, 4, 5. Okay. So I'm going to write here how many collision domains are there? 5. Okay. 1, 2, 3. Switch to switch also we are going to consider 4. 1, 2, 3, 4, and switch to router also. This is one cable. Okay. Totally 5 is there. Okay. Now we are going to see how many broadcast domains are there. Means number of networks, means number of connections to router. There is only one connection to router. Okay. So the broadcast domains is how many? Only 1. Okay. Because this is all comes under one local area network. Right. That's it. The next one is, if you go from this diagram, identify number of collision domains and broadcast domains. So number of connection to switch here 1, 2, 3. Switch plus router also. So switch to router also, this one and this one. So how many? 1, 2, 3, 4, 5. So number of collision domains are here is 5. And how many number of broadcast domains are there? Means number of connections to switch and router. So for the router, if you're going for the broadcast domain here, how many number of connections to the router is 1 and 2. So the answer for here is number 2. Okay. So like that, you can take your own examples and you can ask me how to identify number of collision domains and broadcast domains like this one. Okay. So before going for this one, just I want to review or recap this these concepts here. Okay. So I want to recap here. So the hub is, there is a possibility there is a collisions. Okay. Because it is sharing the same bandwidth or medium. Okay. But switch, it is not like that. It is intelligent. It is using MAC table. It is, each link is going to work like a single collision domain. So in hub, we are going to consider the whole hub is one broadcast and one collision domain. But for the switch, each interface is one collision domain. So if you go for the broadcast domain, so the one LAN, we are going to say one broadcast domain, and because the whatever the frame is going to, or packet sent by the device, it should be broadcasted within the network. It cannot be go out to the other network because the router is going to block that service. Okay, this is what the broadcast domain. So this is a theory. So by default, the hub contains one broadcast domain and one collision domain. The switch contains one broadcast domain and multiple collision domains. And router, every port is a broadcast and collision domain. That is the basic logic. Okay. So what is the important point you have to remember here is, it is possible to avoid collisions and broadcast domains in hub? No, we can't avoid both collision and broadcast domain in case of hub. In switch, is it possible to avoid collision and broadcast domain in switch? Yes, we can avoid collision domain only, but we can't avoid the broadcast domain. Is it 100% possible to avoid collisions in case of switch? No. For example, the switch is working in half duplex mode, still there is a collision. But the switch is working in full duplex mode, there is no collision. Okay. So how to identify the number of collision domains in case of switch? Each interface or each connection work like one single collision domain. Now, router. So if you go to the router, each router connection, we are going to say one broadcast as well as one collision domain. So based upon that, I write, this is the logic. Okay. If you go to this logic here, number of connections to switch and router, please write in paper again. Then you can go to the next slides. Okay. Number of connections to switch plus router, that is called collision domains. Number of networks, that is number of connections to router, that is called broadcast domain. For the hub, number of collision and number of broadcast domains is 1, like this one. This is the logic. Now, if you see here from this diagram, how many broadcast domains are there? What is the answer? Because there is no router, everything comes under one LAN network, and also the hub is going to work like one single broadcast domain. The answer is 1. Next one. If you go here, how many broadcast domains are there? Because the number of connections to router is only 1. That's why only one broadcast domain is here. How many collision domains are there? Means number of connections to switch and router. So there is one connection here, there is one connection here, there is one connection here, totally 3. How many collision domains are there in this one? So each connection 1, 2, 3, 4, 5, 6 and 7. Total cables, 7 cables is there. So we say how many collision domains are there? The answer is 7. From here, we identify the number of broadcast domains. Means number of connections to router. Router contains one connection, another connection. Totally how many? 2. So 2, the answer is number of broadcast domains are 2. Next one, question number 6. How many collision domains are there here? So 1, 2, 3 and 4. Okay. See here, why am this one no need to consider, because the number of connections to hub no need for us. By only we have to consider the switch, because in collision domain each one is work like each interface of the switch work like a collision domain. Okay, 1, 2, 3, 4, but all these connections are connected to some common cable. That's why we have to take only this cable, right? So 1, 2, 3, 4, 5. The answer for this one is how many? 5. Next one. How many broadcast domains are there? There is no routers are there. So everything comes under one broadcast domain, because why? This PC is sending, it is going to broadcast to all the devices like this one. That's why we are going to say only one broadcast domain is there. Next one. How many collision domains are here? 1, 2 and this one is 1. Okay. Totally 3 collision domains are there, because again we are going to consider this all 3 cables as only one. Okay. The last one is, by default the hub is going to work like a single broadcast and single collision domain. That's why the answer is collision domains is 1, broadcast domains is 1. From here, identify number of collision domains means number of connection to switch and router. So there is no router here, so it is 2, correct, as well as one broadcast domain, because there is one like one LAN network. We can say it is only 1. And from this one, identify number of collision domains and broadcast domains here. So if you go here, number of collision domains means how many? 5. So connections 1, 2, 3, 4, 5. We will say 5 collision domains are there. Broadcast domain means number of connections to router here, because each one is work like a single broadcast. This is only 1. And from here you have to identify number of collision broadcast domains. 1, 2, 3, 4, 5 collision domains are there, and number of connections to router is how many? 2. So totally 2 broadcast domains are there. Okay, hope you understand all these things. Okay, if you have any doubt, just contact me. Okay, I'll give you you have any you need much more clarity. But before practicing all these examples, okay, and please understand the concept. Okay, this is the logic. Okay, just I write the logic here. Please go through this logic. Okay, and you have to understand, and you have to write in paper. Then you understand, then you can start practicing all these examples. Okay, otherwise you may bit confused. Okay, that's all. Okay, so that's all about this chapter. Thank you for watching.